Okay, guys. Trying to make sure I'm actually recording here and that you can hear me and everything. Going to do a couple videos here for you to uh, put some word problems behind all the math you've been doing for the last couple weeks. So the big word is contextualizing the math, but we just call them word problems. So here we go and see if we can use some of our techniques to solve these things and answer these questions. You'll start seeing the relationship to like real world applications too. So, as if that's not enough, we're going to mix in our calculator and I'm going to start showing you and expecting that you remember some of these techniques for the next midterm. So, here we go. Take a look at this page. This is from the Pittsburgh packet. And if you read the word problem or pause it, I can read it to you. But pretty much, there's a museum, and they charge excuse me, $6 admission, and on average, 200 people visit the museum. So the manager of this museum's business, they want to increase the price of their admission ticket, but in researching, she's found that for every dollar increase in price, she's going to lose 15 customers. So the manager knows that she can determine the weekend revenue by multiplying the number of visitors by the ticket price. So she has this equation she came up with, and you can see it right there. The resulting equation is r of x equals that negative 15x squared plus 110x plus 1200. So just looking at the graph, notice if I can get my pens working here, x is going to represent the number of dollars that the price would be increased. So right now it's at 6. So notice that's down here. Labeling everything is very important. So if I increase it a dollar, you'll notice the graph goes up because you're going to make a little bit more money. Makes sense? And if I increase it another dollar, well, instead of being here, my new profit, so I went from there, it's going to continue to go up. You'll notice if I don't increase it at all, at $6, this is a $6 price. I'm just talking about meaning here. So at $6, you're making $1,200. So that's what the y-intercept means in this case. All right. Everything is about meaning and what the point means. Notice these points as I'm speaking, I'm talking about what x is and what y is. And in these days, or in these cases going forward, we're not going to have an x or a y. We're just going to have an input or an output. Or in this case, the number of dollars you're going up and the revenue that corresponds with that for the y axis. So if you're looking at that graph and look at number one, it's just going to say describe the shape of the graph. How is it different than linear or exponential functions? And we haven't got to exponential functions yet, but linear functions, if you remember, have a constant average rate of change, and they're always a straight line. So an average rate of change is what defines a linear function, and that has a function. We got to start comparing these things. So that's a straight line. Notice quadratic functions, which is what this is, and you'll know it already because you've already done plenty of work over the last couple of weeks. But that function has the standard form, and some of this you've already seen before. Okay, so y is just like the rx. And in this case, how is this different than linear functions? Well, this kind of goes up. It hits some maximum value. Oh, I don't know, somewhere up in here. And that's called the vertex, which we've discussed already. And then it's going to come down and have x-intercepts here and here. And that's why I wanted to do this one myself with you and just kind of talk you through it. Parabolas are very important in just about all aspects of life, free-falling bodies, and in this case, directly charges for admission to a museum. Now, hopefully you can tie this into movie theaters and baseball stadiums, basketball games. I don't care if you're good theater tickets at a play, anything that charges some kind of admission, the zoo. There are mathematicians behind the scene that create these types of equations right here. And what ends up happening, since we're talking about it, notice I'll change the color of the dots here. But if they're making $1,200 there, and then 13 here, and then the price is going up, at some price up here, they're going to be interested in that vertex. We'll come back to this in a second. But if you look at the graph as you continue, as you keep raising the price, let's say I raise it $5, okay, then I'm maximizing my revenue. But if I raise it $7, $9, you'll see that the amount I'm making starts to come down. So even if you're going to Disneyland, Disneyland can keep raising their prices as long as their mathematician and their figures are working out so that that top part there, which we don't know exactly, we can't eyeball it, but we can figure it out. But the whole goal for all these businesses, Starbucks and Facebook that has ads for TVs and personal ads for whatnot, social media and things. Everybody's trying to make the most possible or maximize revenue. And in this case, you'll notice that as you continue to increase the price, at some point, those X intercepts mean you're not making any money. And if you think about it, I'm kind of answering all these questions. And again, I'm sorry to just kind of keep talking here, but we can answer all our questions just by looking about how the graph's behaving. So in other words, if this is a number of increases in price, so at 13, right between 13 and $14, if the price used to be 6 and I increase it by 13, so then admission's like $19, nobody's going to come anymore. That's what that point means. When that thing hits the x-axis, and yes, we could figure that out too, you're not making any money. Likewise, if I were to go backwards this way, notice -6. If I'm only charging $6 to start with, if I reduce my price, I'm not making any money. If I reduce the price down to -$6, then I'm not making anything because that's all I was charging in the first place. So hopefully all that makes sense. And that's what I'm going to start asking you to do, is to use these problems and draw conclusions. And the hard part is we got to be able to communicate our conclusions. So for number 2, and we kind of skipped over exponential functions, that's coming in the future, so don't worry about that. Number 2 says, what does the graph tell you about what happens as the price is raised? Now I'm not going to write all this in, but you're more than welcome to if you'd like, or review the video again. But as the price is raised, you start making more money until the vertex. We'll find that point. At that point, that vertex, if you keep raising your price, your money or your revenue will come down. So there's no point to go past that mark. So let's see. Use the given information for number 3. So that was number 2. For number 3, use the given information to find the current weekend revenue. Now, the current weekend revenue, if you don't do anything, remember, if it was $6, which is what we talked about here, then my price was $1,200. So you can verify that using the equation if you want. You could actually just plug it in. So if I don't raise the price at all, and I plug 0 into here, I'll just keep talking you through this, and 0 into there, 0 times those two numbers is just going to make 0, and your only value out would be 1,200. So that's how you can validate it using points on the graph. And by the points on the graph, this is the point 0, 1,200. Sorry, it's a little sloppy. Or you could write f of 0 equals 1,200. Okay? Now, if you're going to mark and estimate for number 4, the value of the x-intercept on the left side of the graph, I'm going to estimate that point as -6, 0. Because again, like we talked about a minute ago, if you spend, or you reduce, I'm sorry, not spend, but reduce the price of the ticket by $6, you're not making anything. So that point means you're making no money. Okay? Okay, so that's kind of the scenarios we're going to be going forward with. Let's see if they have any other questions here. Mark the graph and estimate the value of the x-intercept on the right side. So on the right side, if we wanted to estimate that one, maybe 13.3, I don't know, comma 0. And this is the point, just because I'm not writing all this out, on your future questions or midterm questions or final exam questions, when it's asking what does the point mean in the situation, what I'm really looking for is an actual sentence that says, if you raise something to this effect, but more properly written, if you raise ticket price by, you'd say $13.3, right? 0 would be your profit. Understand? So hopefully, just by looking at the graph, you can understand and make some connections and some real life applications to things. Now, you can also view this thing on your calculator. So get out your calculator, and I'll do this with you right now, and I'm going to struggle with it, just like, well, I want to show you me struggling, let's put it that way, because it's how you view stuff. Now, go ahead and plug negative 15x squared plus 110x plus 1200, pause the video, plug it into your calculator, and when you return, I'll do it with you. So plug that in your calculator right now, please. Okay, so if you're back, let's see what they're going to actually ask us to do. You should have that plugged into your Y function on your calculator. And we can get x-intercepts and y-intercepts on our calculator too. Now check this out. We need to get a viewing window before we even get going here. So because I'm going to screen share this with you, be patient with me as I bounce around. I've already gone ahead and plugged it in there. Now watch what happens with your graph when you hit graph. Not a very good picture, is it? So you do have the ability, now I've plugged in everything right, that little blinking space there in the middle is a negative. But what you can do is you can change your window so that you can view things better. Let's just put it that way. And a lot of times what I like to do, I like to cheat. I like to go ahead and look at my graph and rip off the numbers that they have there. Notice my X range. It's kind of like a zooming feature. You can zoom in and zoom out on your calculator, but notice it goes from -7 to 15. And because I don't always want to just cut it off right there, I might want to look for like negative 20 to maybe 30 for my X. So I'm going to go from 20 all the way over to 30 on my X. And I'm going to write that down on another piece of paper to make sure I don't screw that up. And I'm going to count by ones. And then for my y-axis, if I'm going up and down, notice it goes by thousands. So this is going to go from 0 to thousands, 1400. So instead of just going to 0 again, you want to go a little bit past. Notice I'm getting scribbled all over here, but if that's -200, maybe I'll come down here to -800, and I'll come all the way up to, I don't know, 2400. So 800, -800 to 2400. And notice how they're counting in the picture. They're counting by hundreds. Okay? So all I'm trying to get you to do is fill in these blanks. Notice, and I couldn't do both at the same time, but my X min, I'm going to put a 20. I'm going to let it go to, or excuse me, -20. I'm going to go to 30 and count by ones. And Y minimum, it's going to be -800. I'm going to go to 2400. And I'm going to count by 100. Now, what the heck am I doing? Those are my numbers I'm going to use on my calculator. So notice, let's see the question. They want to know the intercept, I think. Use the calculation. Okay, so for x-intercepts, here's how you do it. So again, I'm going to have to go back here and type in those numbers I just typed in. Remember, I got up by hitting this window. You can bounce around here kind of seamlessly. Hopefully you can see my, well, let me bounce over to the calculator so you can see what I'm doing. So hopefully you can see what I'm looking at here. And in this feature, hit the window, and it allows you the ability. So I'm going to go from -20 to x maximum of 30. And here's the hard part. You're never going to get this right. Well, not never, but it's real hard to get it right the first time without a lot of practice. So be patient. The right answer is just the right window that you can get whatever it is that you can. In other words, I'm having a hard time saying it, but the right answer is just the answer that will allow you to get or solve your problem for whatever your needs are. So you can zoom in, zoom out. You can do it this way. And if you have more questions with your calculator, come in and practice. You can watch this again. Go ahead and put those in. And at that point, hopefully everything's in right. Notice my scale. Scale means the numbers by which you're counting. And go ahead and graph and see what happens. And now we have a lot better picture, don't we? So now that we have a good look at stuff, we can figure out the max and the mins. And the first question that they were asking um, in our last problem there was they wanted the x-intercepts. So here's a way to cheat. Hit y equals, and you could do this a couple different ways. And you know what? Let's go ahead and show you a different way. So if I hit second calculate, if you want over here to go to zeros, because intercepts are also called zeros or roots, go ahead and hit that 0 button. And then your calculator is going to ask me for a left bound and a right bound. And all that really means is they want, sorry if I'm going to draw over this, I might get myself in trouble here. But because I'm interested in this point here, that's my 0. If you want to do it with the calculator, you're going to have the calculator make a left bound. Watch what happens when I hit enter, but I have to do this the right way. Oh, shoot. I'm blanking on how to turn this thing off. So we'll just share again. So let's see if I can hit enter on that button. And see what it did? It made me have a left boundary. And then what you're going to do, you're going to scroll down. It doesn't really matter where, as long as you're to the right of it. Right bound just means the left is on the left of your intercept, the right is on the right of your intercept. And now your intercept is kind of in between there. You see what I'm saying? So hopefully that's okay. And once you're there, hit enter one more time. And notice your 0 is at 13. Boy, we guessed real lucky. 13.33 y equals 0. So if you missed any of that, you can always do that real quick. Again, watch this. Second. See this calculate feature up here? Calculate 0. And if you wanted the other one, you could just come over here and hold this down. Now watch. Left bound. It's there. That's to the left of the intercept. I'm going to come over. Hit enter for the right intercept, or right bound, I'm sorry. And then enter one more time because your calculator gives you a chance to guess. Hit enter. There's my 0 at 0, or negative 6 comma 0. Okay? Now, since I'm talking about it, and I know the question's coming up, we can also find the vertex, or the maximum value, the same way. So if you just click second calculate, and go down and find your maximum value. If you wanted a minimum, you could do the same thing for minimum. But go ahead and hit the maximum. And again, if I wanted the maximum profit in this case, right, for the museum, notice there's my left bound. I'm going to go to the right of, I know my maximum is somewhere in between there, right? And I'm going to hit enter. And what that's doing, it's telling the calculator, go ahead and find the highest y value or my maximum. Don't worry about the guess, just hit enter. And there's your maximum. So your maximum, if you write that down somewhere, look at your x value, is 3.66 1401 for a y value. Now, what does that mean? Well, really, and I'm not even working off the sheet anymore, that means for $3.66 increase, so for an increase, and I'll ask you verbatim, what does that value mean? And if you just tell me x is 3.6 and y is 14.01, that won't zero points. In the context of the problem or explain the solution or what does that mean, there's all different ways to say explain what's going on. So you could physically say for an increase of, what is that, 3.6? So your ticket price is now 6 plus 3.6. Or ticket price of 9.6, maximum revenue, or you can say you'll make a max revenue. Gosh, can't spell. Of $1,400, or approximately 1401. That's right in front of you. So that'll be your max revenue. Okay, so that's what it means. And the expectation, I hope I'm communicating it clearly, will be that you write a nice English sentence, not chicken scratch like I'm writing. So bear with me, and I'm just doing it because I'm limited on this this pad here. Okay, so remember those numbers. Let's go back before this video ends here. See if we can tie up all these loose ends. So for 6, we talked about it. the x-intercepts, right? One was -6, 0, and the other one was, well, the right side, I guess, was right here. But we got lucky with the 13.3. That was just pure luck. Then we went in and then we graphed everything on our calculator. So we were close. And then let's see, find another point on the graph that shares the same y with the y-intercept. So what they mean with that one, and notice we can verify our estimate in the graphing calculator. So let's take a peek at what they mean. So they're saying the y-intercept has a value at 1200. And I don't know if my eraser is going to really erase some of this stuff. Maybe I should be erasing, maybe I shouldn't, I don't know. But for 1200, this point here, if they're saying mark another point on the graph, another point on the graph would probably be right in here. With me? So that value here, I don't know, would be approximately 7.5, 1200. And I guess what that question's trying to show is that, and they're going to say, well, what does that mean? Because if I don't raise the price at all, I'm going to make $1,200. But if you raise the price $7.50, I take this amount and go up with it. So this is what that question's looking for. If you go up by $7.50, then the price is still going to be the same. So why would you do that? Keep it lower, right? So in other words, and parabolas have this feature that every dot on the left, y, there'll always be a mirror image on the right. Same thing. So this y will match this y over here. They'll just have different meanings and different uses, depending on the context of whatever the problems and how the problem's coming at you. So we can actually figure that out exactly if we wanted to. Notice our approximate coordinate was, I already lost that, 7.5, and that was just me eyeballing it. So we just talked about what it means. So 7.5 increase yields the same profit of $1,200. Okay. And you could verify that on a calculator by doing this pretty quickly. Now, let me go ahead and hopefully I'm going to share the right thing with you. If I'm going to look on my calculator, here's another trick. Now, you could go around and wait for your y value to plummet. Oop, now watch this, trace, to about 1200, right in there. But sometimes my graph just is not good enough. So a trick to find intersections or for systems of equations is come down. I just went to my y equals button. You can watch it again if you need to. And click 1200, and what's going to happen is now you have a spot where this graph's crossing. So check this out, and then we'll end the video, because this is enough, I think, for this one. Second, calculate. And this time, I notice that second feature is just like a shift key. If I come down here and I want to find the intersection, your calculator is going to ask you what two curves. Now, straight line is also a curve, okay? So just hit enter, first curve, second curve, hit enter. Doesn't matter which one you call the first or second. And then your calculator will give you a guess opportunity again, and just hit enter one more time. So that's the first intersection. Now that's not the one I wanted, right? So let's do it again. Second, calc, watch how I'm going faster now. Intersection, but I'm going to move over where I'm more interested in. I want to know this one. So first curve, enter, second curve, enter, bypass the guess. And there's my intersection, 7.3. So we were off a little bit, or I was, but you get the gist, hopefully. So my answer really is 7.3. Okay? So 7.3, and we were close. Now this last one's probably the most important, but we've already talked about it. We used the precise vertex to find that I think was 1401, and that an increase in price of 366 would give me the precise vertex. Okay, let's see, anything else for now? No, I think that's good for this video, and I will come back and we'll talk more about this next group problem in a minute. But I'll tell you what, since the next video is going to be on that, go ahead and give that a shot for practice, and I'll come in and show you all the answers in a sec. Okay? All right, bye for now.